Welcome everyone to this video. We are going to discuss a question from the book Verma. Question is regarding an electron, and basically we want to find the ratio of the magnetic moment associated with an electron to its angular momentum. So let's begin. So what we are given is the radius of the circular path of the electron. R is the radius of the electron. B is equal to speed of the electron. The current I of the electron, or what is the current? There's basically charge flowing per unit time through a point. So imagine okay, this is how the electron is going. So the time taken by the electron to complete one particular circle would be simply the circumference 2 pi r divided by v. So we can say that the charge of the electron is E and the time taken is 2 pi r by v. So this means the current is EV upon 2 pi r. Next, we will find what is the magnetic moment of the electron. The magnetic moment is simply current into area. Current is EV divided by 2 pi r, and area is pi r square. So this is the magnetic moment. Next, what is the angular momentum? So angular momentum of electron is simply mv r. This is true for any particle going in a circle of radius r with the speed v. Uh, so what is the ratio of angular momentum and magnetic moment? L by mu. So this ratio, as we will see, is equal to simply m 2m upon e, or magnetic moment divided by angular momentum is equal to e upon 2m. This ratio is called gyro-magnetic ratio. So soon you'll study in Bohr model of hydrogen atom that angular momentum of an electron is quantized. So because of which the magnetic moment of a electron is also quantized. So by quantization we mean that that it would be integral multiple of some fixed number. So this was magnetic moment, and its ratio with angular momentum. So it has a fixed value. After substituting the value of E and M, we can get that particular value. So this was gyromagnetic ratio. Thank you for joining and have a good day.